All right, we are live from Studio 203, and we have our live audience, Boston, my Boston class, and we are going to be working on Lesson 5, Stretching Parabolas and More Completing the Square. So when we take a look at some of these equations, all right, we've got our standard form here that we've been working with, and we've also been taking that standard form and putting it into vertex form so we can look at some other pieces of the parabola. So when I take a look at A, and I look at the examples that they're giving me, and they're saying use your calculator and then sketch a graph of each one of those on the axis below, and it's telling you to use the window indicated. So make sure that you're able to change your viewing window on your calculator to what's given here. I'm going to let you do that on your own, and then I want you to be able to write down some patterns, some things that you see happening, because that's going to help you to answer B. So today, A is sort of going to be the star of our show. All right, so A, in terms of, we're looking at what A does in the standard form, and then we're going to continue to look at what A does down in exercise 2. So exercise 1 and exercise 2, you're going to do on your own. You're going to come to class with those done. All right? So keeping in mind that A is the star of our show today. Okay? Now if you go ahead and flip the page, it says, since all quadratics of the form y equals ax squared have their turning point at the origin. I'm just going to shrink this down a little bit because the view is looking a little large and in charge here. All right, that's better. So this, turning points at the origin. What happens when A does not equal 1 and you're in vertex form? Okay. So things start to get a little bit tricky. It's not going to change our vertex, but it's certainly going to change the work we're going to have to do in order to complete the square, in order to go from standard form to vertex form. So in our first equation in exercise 3 in standard form, we've got to complete the square so we can put it into vertex form. So that 2 in front causes a bit of a problem. So how do I deal with that problem when I'm starting to complete the square? I'm just going to rewrite it as it is. And now how do I work with that? So when we started to complete the square, we were looking at our first 2 terms. So hopefully you're recognizing that 2 in front is our GCF. Now it's not a greatest common factor. We're just going to go with that it's a factor that we need to not eliminate, but bring out in front. So now when you look at that x squared minus 6x, that's more like the binomial we were dealing with yesterday when we were completing the square. And I'm still going to shove that constant of plus 11 over to the side. Now I start my process. So I need to be able to take half of b and square it. So my b right now is that negative 6. So if I take half of negative 6 and square it, that's going to become 9. So where am I going to place that 9? I do have to extend my parentheses just a little bit. But I'm going to keep my pen red. So notice now that I put the parentheses there, but I put that plus 9. So in order to create an equivalent equation, think to yourself, I've got this 2 that's out in front, so really I haven't just added 9, I've added 18. Because the 2 out front times that 9, I'm adding 18. So truly, what do I need to subtract to keep that equivalency? I need to subtract 18. So I'm going to write it in sort of a funky looking form, but just so you get the idea of it. Okay, so let's continue, and whoops, I should have this in blue. So y is equal to 2 out in front. Now let's factor that perfect square trinomial. What is that? That's going to be x minus 3 squared. And now we've got to combine our like terms. We've got negative 18 plus 11, which gives us negative 7. Right now, the vertex has not changed. That 2 in the front, that A, does not change the vertex at all. Remember that the A just tells us how wide or how narrow our parabola is and whether it opens up or down. So the vertex is 3 to the right and 7 down. So, part B says, what are the coordinates of the turning point of this quadratic based on A? And I'm just going to shift that over because we just answered that. And it says, provide evidence from the calculator table that supports this answer. So what you're going to do on your own is you are going to go to your calculator and generate a table. And right in the center of your table is going to be that turning point. Okay? So you're going to do that on your own. All right, so let's continue, and we'll do another couple questions dealing with completing the square, so going from standard form to vertex form when our A is something other than 1. All right, so let's look at letter A. And our A is 5, so start that process. So I'm going to take and group our first two terms, but I'm going to get rid of that A, or sort of shove it out in front as a factor. I'll leave a little space, and then I'm going to bump that 23 over a bit. So now I'm starting the process of completing the square. So I'm going to take half of my B. So half of that is 2. 2 squared is going to be 4. So I'm going to add 4. But because I've got that 5 factor out in front, I'm not just adding 4, I'm technically adding 20. So in order to offset adding 20, I have to subtract 20. So I'm going to write that just as is. So now I have my equivalent equation. I've established my perfect square trinomial. So now I just need to factor and combine my terms. So that's going to factor into x plus 2, the quantity squared, plus 3. So what is the vertex of this parabola? Let's see what the question asks us. Oh, it does. It says identify the turning point and state whether it's a maximum or a minimum. So my turning point, or my vertex, is negative 2, 3. And by looking at A, because I said to A was the star of the show, it's a positive number, so that tells me that my parabola is going to open up, or it's going to smile. So therefore, my vertex is down there. That tells me that my vertex or my turning point is going to be a minimum. All right, we'll try one more. Let's try letter C. Now, I'm staying away from B and D right now because my A is negative. I'm going to see what you guys can come to class with B and D done, being that the A is negative. The process is still going to be the same. You're just going to really have to watch your signs. I know you guys can do it. All right, last one. So my A is 6. I'm going to take that 6 out. So x squared minus 4x. I'm going to leave a little space, and I'm going to bump that 14 over. So now I've got to complete my square. So I'm going to take half of -4, which is -2, and then I'm going to square it, which is +4, but I didn't just add 4, I truly added 6 times 4, which is 24, so I've got to subtract 24. Now I can factor, so it's x minus 2, quantity squared. Combine like terms and get -10. My vertex, or my turning point, is to -10, and because A is positive, my parabola opens up, therefore making that vertex a minimum.